All right, lesson 7.7 out of the Sullivan book is about tangent, how to graph tangent, cotangent, cosecant, and secant. So we're going to start this off like we did before. We're going to think about a circle and an x and y axis going through the circle. And we're going to think about a dot here, and the dot is going to be going around the circle. Except for this time, we're not keeping track of just y or just x like with sine or cosine. We're going to keep track of x and y at the same time because that's the tangent ratio is y over x. So I'm going to put theta here, tan theta here. So right now I'm at 0, and the tangent of 0 would be 0 because it's y is nothing and x is 1 over 1. When you move to this point here, you're at 45 degrees, or pi over 4. Well, the slope here would be up 1 over 1, so it's 1. When you go to here, you're at 90, or pi over 2. And that slope would be straight up and down. Notice x is 0 when you're up here, because this would be the point 0, 1. So x would be 1 over 0. So it blows up. So it's undefined. That makes sense. Find. Can't spell. So 0, 45, pi over 4, or 90 degrees. And straight up and down, when you think of algebra 1, a line that's straight up and down has undefined slope. Then we go the other direction. And the reason why we go the other direction is because it has to do with the way the graph is connected together. So we didn't do that with sine and cosine in my explanation so much. So I'm here. That would be negative pi over 4, negative 45 degrees. And it's sloping this way, which is a negative slope. So it would be negative 1, and negative pi over 2 would be down here. And that would be also undefined. Look at me spelling it correctly. Now I'm going to graph this, and so I'll make my x-y axis. So I go over pi over 4, over pi over 2, over pi over 4, over pi over 2. In the negative direction, it blows up. It blows up, so we make these vertical asymptotes. And I'm going to call this 1, and I'm going to call this negative 1. So switching to a different color, I guess I'll do red. So at 0, it's 0. At pi over 4, it's at 1. At negative pi over 4, it's at negative 1. So it looks like it makes a straight line there, but it doesn't. It makes this curve thing, like a snaky cave, almost like the graph of x cubed. X cubed kind of makes a curve like that, but it's a little bit different shape. Well, the deal with this is this S-shaped curve here just keeps repeating itself over and over again. So if I do this, I'm going to do the same thing right here. So then this would be where it blows up. This would be where it's 0 again. This would be where it's 1. This would be where it's negative 1. So it blows up like this, like this, like that. So where are those points? Well, it repeats itself every pi. So if this is pi over 2, then the pi later would be 3 pi over 2, because that's a half, and then you go over pi more, that'd be 1.5. So that's where it blows up again. So if this is 0, right, then this would be pi. Pi is where it's 0 again, which makes sense because if you're going around the circle here, pi. And pi would have a slope of 0. See, pi has a slope of 0. And then it just keeps doing this over and over again, right? Boom, boom, and place where it doesn't blow up. It also goes the other direction that way. So here's the graph from the book. So you can see it blows up at pi over 2, 3 pi over 2, 5 pi over 2. But notice it's the same thing plus pi later, or it's the same thing minus pi later. All right. So because of that, and because of the weird blowing up of this, we talk about the range of this. Range is the y values. The range is all real numbers. But the domain is messed up. The domain blows up. And the domain of this would be all reals except here, which is pi over 2. And then you could go forward pi and back pi. And you could go forward 2 pi, or you could go back 2 pi from here. So what we do is we say, except for theta equals pi over 2 plus or minus in pi, where in is the whole number 0, 1, 2, 3, dot, dot, dot. So you can go forward 3 pi's or backwards 3 pi's or whatever. Those are all the places where it blows up. That's the sine curve. But again, it makes a snaky curve, and it keeps repeating that little bit. The period of this is shorter because it repeats itself not every 2 pi, but it repeats itself every pi. So the period is pi over omega instead of 2 pi over omega. And I think that's all the stuff that yep, that's all the things in my little notes that I made about this. All right, so if you can do tangent, then you can think about cotangent. Cotangent is x over y. So every time y is 0, it blows up. So when y is 0, which is here, right, and here, so it's going to blow up at 0, it's going to blow up at 180, it's going to blow up at 360, which is 2 pi, it's going to blow up at 3 pi, 4 pi, 5 pi, 6 pi, as it goes around the circle, or negative pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5. It just keeps blowing up every time it hits the x-axis. So that's why the cotangent curve looks like this. So this is cotangent. Cotangent of theta is equal to y. We'll use that notation. So the period's the same. Now it blows up every pi instead of every instead of doing pi over 2, it blows up at pi, so it's 0, etc. Now if you think about it, this makes sense that these dots are here and here, because if you take 1 and flip it upside down, you have 1 still. If you take negative 1 and flip it upside down, you still have negative 1, because tangent and cotangent are reciprocals of each other. So it makes sense that those dots are still the same. So pi over 4 is 1, and on the other graph, pi over 4 was 1. And then this graph here is the same thing. The difference is the tangent graph did this. It was like, it blew up here, and it blew up here, right? But it shared this point, and then that was your 0, so it went like this. So it's the same curve, right? Or the same shape of the curve, it just got flipped and moved around because of the reciprocal nature of the problem. Okay, now, how do you graph secant and cosecant? So basically, what you do is you just graph the sine curve. So I'm gonna reveal it under my hand down here. So here is cosecant theta. This is how you graph this. So what you do is you make a regular sine curve. Mountain, valley, right? And then we'll even do it this way. So this is 1 over sine theta, which means it's the flippy upside down of sine. That's what this is. Well, if you take 0, right, which is right here, and you flip it upside down, that doesn't work, right? It's going to blow up. And if you take 0 and flip it upside down, you're going to have 1 over 0, so it blows up. So everywhere that sine is 0, you make these vertical asymptotes, because that's where it blows up. At the top of the hill, it is 1. Well, you flip 1 upside down, and it's going to be 1. So it makes these parabola-like figures in between each one of these vertical asymptotes. So you flip 1 upside down, it's 1. Somewhere in here is a half. You flip a half upside down, you get 2. You flip 1 over 100 upside down, you get 100, right? So it flips it up like this. And then so this one's this way, this one's this way, this way, this way, this way, right? This way, this way. So the blue is the actual graph of it. So that's how they graphed it down here. So we're back to the normal stuff. We're back to like 2 pi over omega for the period. Because basically, you just graph the sine curve and you figure out where it's 0. You make your boundaries and then you make your U-shapes. So the graph of this is here, 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 and there. That's the graph. This is cosecant, which is written right there because it's part of the relationship with sine. So you do the same thing with secant. Here's your secant graph. So the first thing you do is you make your cosine curve, and then everywhere it's 0, you put your boundaries in, and then you flip it upside down, and you make these parabola-like things. So the secant graph, so right there it says secant, and these graphs I just stole out of the book. Right? So you can look in the section 7.7 and you'll see those graphs right in the book. But that's the graph you want, is that orange thing there. You do the cosine curve just to help you. So here's the assignment. So we're skipping 37. I don't remember why, but we skip 37. All right. So everything else is the same. Here's 27. So we got to think. We're going to think sine, right? We're going to think sine. We're going to think 3 sine, and we're going to think 3 sine flipped upside down. So it's going to go as high as 3 and as low as -3, because that's your amplitude. The period's still 2 pi, so we're going to go 1, 2, 3, 4. 1, 2, 3, 4. So we're going to call this pi. We're going to call this 2 pi. 1, 2, 3, 4. 3 pi. 1, 2, 3, 4. 4 pi. And it's going to be negative first, right? So it's going to make it go down first instead of up first because it's flipped over the x-axis. Okay, and in the middle, here, middle, there, it's up and down 3, right? Valley followed by a mountain. So that's that graph. Now we go through, and everywhere it's 0, it's going to be a boundary because you flip 0 upside down and it blows up. Now put the, okay, I'm going to use green, see what happens here. Boom, 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 boom. And there's the graph, the green stuff. Ta-da! All right, let's do a secant, cosecant. Oh, here's a tangent one. All right, so the first thing I'm going to do is it says +1, so I'm going to shift it up 1. Okay, so it's pi over omega, which is 1/4, so it's going to repeat itself every 4 pi. That's the period. All right. So normally it blows up at pi over 2. So that's where it's going to blow up the first time. So I need to go over to 2 pi. So I'm going to go over 1, 2, 3, 4. I'll do 4 spaces. So this will be 2 pi. So this is going to be the first time it blows up. Because if you put 2 pi in, 2 pi over 4 would be pi over 2. Yeah, so it blows up there. And then the period is 4 pi, so that means it's going to blow up 4 pi later. So I got 1, 2, 3, 4 is 1 pi. 1, 2, 3, 4. There's 4 pi. 1, 2, 3, 4, 6 pi. Okay, so it's going to blow up at 6 pi. So we know that it blows up here, and then 4 pi later it's going to blow up again, because that's the period. It's going to be 0 here in the middle. Now, when is it going to be 1? It should be 1 halfway in the middle here. So it'll be right there, it's going to be 1. And then halfway in the middle there, it's going to be like at -1. Because there's no amplitude in the front to bring it up or down. So it's going to be like this, through, like that. And so this one here, halfway in the middle, it's going to be at 1, and then it blows up like so. So that should be it. Again, you can type these into the calculator and see if we did it right. There's no secant button on the calculator, so when you type it in, you got to type it in as 1 over cosine of this and this. So you have to type it in that way. All right, so that's how you do these. Peace out.